So already we have seen that refractive index mu is equal to sine of A plus D minimum by 2 divided by sine of A by 2. Okay. Now suppose the angle of the prism is very small. Suppose the angle of the prism is small, let us say it is less than 10 degrees. I can, instead of the angles, I can substitute the sine theta by theta, tends to 1. So I can say mu is equal to A plus D minimum by 2 divided by A by 2. So the 2's get cancelled. So I can say A into mu minus 1 is equal to D minimum. So you get straightforward questions in certain exams. They will say the angle of the prism is 10 degrees. Refractive index of the medium is 3 by 2. What is the deviation? So it is simply 10 into 3 by 2 minus 1. So that will be 5 degrees. So the minimum deviation is 5 degrees. Okay, which means that if I have light of different colors, they will have a different deviation. So red light will have AR, mu r minus 1 as its deviation. This is the deviation red. Now deviation violet will be, A is the same, whether it is red light or whatever light, A will be the same. So it is not correct for me to say AR. So A into mu r minus 1. Similar, the deviation for violet will be A into mu violet minus 1. Now we know that violet gets more deviated than red. So we will say that dV minus dr is what is called as the angle of dispersion. Angle of dispersion is the deviation suffered by violet minus the deviation suffered by red. Violet suffers a greater deviation because it has a lesser lambda, hence greater mu. So if mu is greater, the deviation will be more. Then that will become equal to A into mu violet minus mu red. Okay, so this is called the angle of dispersion. Now if this is the angle of dispersion, then I can say that the deviation of yellow light is A into mu yellow minus 1. So from here I can say that A into mu violet minus mu red divided by A into mu yellow minus 1. This is the angle of dispersion, or angle of dispersion divided by average dispersion. Average dispersion is what is called as omega, the dispersive power. A's get cancelled and I'll get omega, the dispersive power. The dispersive power of a lens or of any material is a property of the material. It is not a property of the geometry. And this dispersive power is equal to mu violet minus mu red by mu yellow minus 1. Okay. Later on we will read something called as chromatic aberration. If the dispersive power of a lens is less, chromatic aberration is less. So we would want to avoid chromatic aberration. So the way you avoid chromatic aberration is by decreasing the dispersive power. So you make material which has lesser dispersive power. Okay, so this is how you work as far as prisms are concerned.